Hey, look, we made it to the last section of the notes. Usually that means a test is right around the corner, but not now, so let's get into this and enjoy the math. So I'm in your notes on page 18, and let's go ahead and we'll get right into it. So this is how we can use mirrors together with similar triangles in order to measure the height of an object. So this is going to be very similar to the last lesson that we did on using shadows to measure the height of an object. So they've drawn you a nice picture of what they're calling the mirror method. So they said the mirror method is illustrated below. Place a mirror on a level spot at a convenient distance from the object and then back up from the mirror until you can see the top of the object in the center of the mirror. So it says the two triangles that are drawn in this picture are similar. Here's how come. So first things first, where are the two triangles? I'm going to make that first triangle red, and you know I love my colors, so I'm going to make the second triangle purple. And we know that our objects in the picture are always going to stand up in such a way that they're perpendicular, or that they make a right angle with the ground, or that they stand up. And the second fact that you need to know is that the light will reflect off of the mirror at the same angle at which it arrives. So in other words, when the light comes down this way and hits the mirror and then bounces back up that way, those two angles at 1 and 2 are going to be the same. So the two triangles will be similar by angle-angle similarity. So where the first pair of angles being the right angles, and the second pair of angles being at 1 and 2 where the light enters and then reflects. So the triangles are similar based on angle-angle similarity. And this, of course, means that the lengths of the sides are going to be proportional. So why does using the mirrors and the similar triangles to measure height work? Down at the bottom? Well, it all has to do with the fact that the light reflects off the mirror at the same angle at which it arrives. So if your light is coming down this way from the top of the light pole, it's going to hit your mirror and bounce back up. Those two angles at which the light arrives and the light reflects are always going to be congruent to one another. The objects are always going to be standing straight up at right angles. So again, we have this whole angle-angle similarity situation going on. All right, so let's now flip up to the top of the next and last page. That's something to celebrate in these difficult times. And let's go see how we can use this to solve a problem. This says that Jim is a student in Mr. Anwar's class, and he's using the mirror method to estimate the height of the school building. He's found the following measurements. He's found that the height of the ground to Jim's eyes is 150 centimeters. The distance from the middle of the mirror to Jim is 100 centimeters. And the distance from the middle of the mirror to the building is 600 centimeters. Estimate the height of the school building. Well, here's how, if you're creative, you can get really fancy with some pictures. I'm not such a good artist, but there's my school building. Probably should put a door in there so that people can get in and out. Here's Jim. Well, that's good. Jim is like flying up in the air and half the height of the school building. Let me go back and redraw that a little bit more accurately. There's my boy Jim. And then we've got this mirror somewhere in between them. Those two angles, again, at which the light comes in and the light leaves are going to be the same. Let me draw my flat level surface. Of course, Jim is standing up at a right angle. This building is standing up at a right angle. And now I've simply got to get the measurement in there. The first one, the height from the ground to Jim's eyes, 150 centimeters. So there's that right there. The distance from the middle of the mirror to Jim. So here's my mirror. That distance is going to be 100 centimeters. The distance from the middle of the mirror to the building, 600 centimeters. And we are, of course, trying to estimate the height of the school building, so I'm going to call that x. And you guessed it, I've got the situation or the scenario with two different triangles, the blue one and the purple one. Notice, though, that the way that in which these triangles are drawn, those right angles don't match up. So I'm going to redraw these so that the right angles are in the bottom left and the mirror angles are in the bottom right. So in other words, I'm going to take my purple triangle and kind of flip it around. So in my red triangle, x is that height of the building, this bottom length is 600, and in my purple triangle, the bottom length is 100, and the length of the left side by that right angle is 150. So again, I've got this whole idea of the triangles being similar by angle-angle similarity. And if the triangles are similar by angle-angle similarity, that means that the sides must be proportional. And like I've done all along in this unit, I'm going to put the lengths of the small triangle over their corresponding lengths in the larger triangle. So if I look at my picture, I've got x over 150 equals 600 over 100, or I could do 600 over 100 equals x over 150, except I just realized that I want to go backwards because I want to put small over the large. So 150 over x equals 100 over 600, or 100 over 600 equals 150 over x. Either of those is going to result in the same proportion. Once I get my proportions set up, all I have to do in order to solve it is to cross multiply it. So when I multiply 150 times 600 on my calculator tells me 90,000. So x ends up being 900. My all measurements were all in centimeters. And if I go back and look at my picture, they were asking me to find the height of the school building, but I let x be the height of the school building. So at this point, I've completed the problem and the unit. Good job, folks. Well done. We made it. We are at the end of the unit. Great job. Thanks so much for hanging in there and sticking around. As always, Miss Andre and I are missing you guys like crazy. Can't wait for the day when we're able to come back together. But till then, stay healthy. Keep your family, your friends, your loved ones safe and in good spirits, because at the end of the day, that's what's really truly important. Miss you guys. Can't wait to see you again. Bye now.